Thanks everyone. Glad to see a bunch of people here in Sunnyvale. My name is Erik Freeland. I'm with a company called Nubeva. You probably have never heard of us, though a few of you may have. I'm very specifically going to talk about using Moloch with AWS VPC traffic mirroring. One of the things I always try and do is figure out the who, what, when, where, how, why. That for me is always how I kind of try and focus on things. So really what I'm presenting, this will actually be a complete CloudFormation template for an AWS installation of Moloch. This is actually a preview of an official AWS quickstart that I'm working on with AWS. So everything you're going to see actually will be pure open, it's already open source, but everything you'll see will be full open source with AWS probably towards January, though everything I'm going to show you works now and is available today. Some of the core requirements we had must be cloud native components that can all auto scale. So this is not an individual AMI that will just crap out because you throw too much data in it. That is not how I believe this should be built. It's also decoupling Elasticsearch from the capture and the viewer modules. Centralizing all the packet storage on S3, ensuring that we can still support multiple viewers as needed, and allowing for the installation into a new VPC or an existing VPC. So that's kind of what I'm going to be talking about, who I am. Again, my name is Erik Freeland. There's my Twitter handle. You won't see me on Twitter much because it's a cesspool. Feel free to send me an email if you want. Glad to answer anybody about anything. I've been doing in computers for about 25 years. I actually started on a Banyan Vines. I do not remember any of it, but I remember I had to study it once for a test or two. And now, for whatever reason, I'm working on AWS. No idea how I got here, but it's been a long time. What I do currently is I'm the Director of Customer Success for Nubeva. What that means is I own all things customer facing. I'm not a sales guy. I'm kind of an SE. I'm kind of a sales guy sometimes, so I'm sorry. I promise not to try and sell anything today. What Nubeva has done, we actually believe and we know we've solved out-of-band TLS decryption in the cloud. And by cloud, I mean public cloud, private cloud, hybrid cloud. If you're all metal, I'll call that a metal cloud. I can work there too. And it's a way that you can actually get decrypted visibility, even if you're using TLS 1.3 or 1.2 with PFS, but more on that. I'll talk a little bit about that. I more want to talk about what we're doing with Moloch. Why you should care about kind of at least the way I think we're with how we're going with this type of architecture. If you're not familiar with Wardley maps, the one thing you could take away is look at, I believe it's Stephen Wardley's his first name, I can't remember. Look at Wardley maps and how he views IT and how you view IT projects. I actually think it's a very unique way of thought. And very specifically, it's how do you make things more of a commodity? How do you utilitize everything possible? And in looking at how to build Moloch in the cloud, it very much was that. How can I ensure everything is a utility? That as something fails, it's replaced, it's fixed, that I don't have to worry about these bits. Very high-level demo diagram, because I'm going to do this live and we're going to hope it works. It looks like that. I'm going to a little bit more and deeper of kind of what that really looks like, but at its heart, it's this. Bunch of sources, sending some traffic, all being replicated by AWS mirrors, and everything going to a Moloch packet capture engine. So fairly quickly, of course, as you would expect, here's Moloch. I mean, everyone has seen it. In theory, I'm going to refresh that and we're going to see actual data. Fantastic. So live data coming in. You've all seen, you've all seen the screen. I'll come back in a second. We'll look at a couple of bits, but at least we can show, hey, look, seeing data. This is all in AWS. So everything I'm showing, all the sources are in AWS. Everything. I'm going to dive one level deeper then. This is what the actual demo diagram really looks like. Now I'm going to go through this fairly in depth. Everything is set up, and I have to remember that there's a step there. That was fun. All right. Everything is set up in an AWS well-architected environment, meaning there's private subnets, there's public subnets, there's NAT gateways, there's an internet gateway, all the routes work. Everything is set up in a fully highly available environment as well. So in this case, all the viewer traffic, when it comes in, everything hits a front-end load balancer. Load balancer sends it to any capture point that's up, any capture viewer. Doesn't really matter. Same thing with the VXLAN traffic. All the VXLAN traffic also goes to the load balancer, all using AWS mirrors. Now, AWS, with the mirrors release, also released support for UDP load balancers. Now, what you will notice is there's no stickiness session inside of that, but by default, it does do 5-tuple flow stickiness, for lack of a better word. So it will stick a conversation on a capture point as long as that's coming in. All of it comes into Moloch, so Moloch then sits to whichever member of the auto-scaling group it wants to. All of that is done just in standard AWS ASG setup. But the other points that we're starting to do, we are using the AWS Elasticsearch service. So there's no Elasticsearch to set up. There's nothing to set up even on the Moloch capture point itself. Everything is centralized into the same VPC. So what this means is the database is now fully decoupled from all of the capture points. New capture points come up, they go away. It doesn't matter. The database is still all in Elasticsearch. Likewise, all the PCAPs being stored down in S3. So as that data comes through, pull it off, store everything in S3. Again, we simply don't care how many capture points we have. I will also say, watch this space. There's some really cool things we're working on and we can't talk about actually with AWS that we think is even going to revolutionize how this is done. But anyway, that's the basic diagram of what you just saw. And from an availability standpoint, it is available now. If you just want to remember something short, you can just go to nubeva.com. Yeah, you got to log in, but if you log in, you'll see the site. It's all there pretty clear. Otherwise, they're all right here. That's where all my links come from. They go right to that spot. Like anything, there is a little bit more that we've added. What I actually want to show is this is actually what's on that CloudFormation template. So when I was working on this, I had the idea of, well, could do Moloch, that's cool. Well, what if you do ntop? Well, that's cool too. What about Wireshark? Oh, Wireshark's kind of cool too. And Suricata and Zeek. So right now I'm still, my Zeek and my Suricata are still kind of in development. Expect to have them done about another 3 or 4 weeks. It's materially done. But all of this is in that CloudFormation template that you saw, all selectable on which solution do you want to deploy. Do you want to deploy Moloch? Yes. Simply ask you the question, choose which of them you want to deploy. Likewise, if you want to deploy into a new VPC, it will create all of that using the AWS VPC, new VPC quickstart. Bastions, whole 9 yards. Everything's deployed by default. Or deploy it into an existing VPC, check what you want. Same thing, every bit of that's deployed by default. As I said, this is actually the official quick start we are working on with AWS. This will be out after reInvent. And at that point, it will become one of the 170 or so AWS quick starts that are out there. And again, it is completely open source to use however you wish. As a matter, so with that, let's say, but like anything, but wait, there's more. So what I want to focus on is, you saw a picture a little bit of the kind of what AWS mirrors look like. Very specifically, you set targets. In this case, I've set load balancer targets. You could also set network interfaces, but as you can imagine, when you set load balancers, just another way to make sure you're paying AWS, I suppose. But again, you never have to worry about traffic going where you don't expect it. It always ends up at the right place. But more importantly, I want to look at the filters I'm actually using on this traffic. I'm only sending 443 traffic between the sources and the tool and Moloch. And I say that because I'm going to go back to Moloch. I don't want to look at the traffic. And you're going to notice, for instance, right there, that's not port 80, or that's not port 443. That's port 80. You'll notice right below it, that's the exact same source port number, It's the exact same source dest IP. It's the exact same timestamp. If you open that up, you'd probably guess what you're going to see. You see that it is TLS 1.2 originally. Did I open the 443? Yeah, I did. You see it's TLS 1.2 elliptical curve Diffie-Hellman. So I in no way should be able to break this in an out-of-band method. Except, if you look at the same packet, I certainly can. So what we, it just showed that as well, there's really nothing up my sleeve. If it's going to, we look down here, BBC, there's BBC traffic from port A. What does it look like when it comes through? It looks, so, by the way, they're all decrypted. That is my BBC session. Also does TLS 1.3. But back to the question of what do they look like when they're together? Here, let me just find it. Is there one where they're tiled right on top of each other? I can stack them like that. So to answer the question on how do we see them come in, it's actually just like this. So everyone's kind of got an idea of what's happening under the covers. What we're actually doing is we've invented a way that we can extract and discover the final symmetric keys on any host. When we see that SSH TLS handshake happen, we're able to extract the key, send that key in essence to Moloch or whatever that end tool is. That end tool has a decryptor on it. That decryptor, as it's receiving that VXLAN traffic, when it sees that TLS traffic come in, it's able to grab that symmetric key, and at the same time as it's sending out that encrypted data, it will also decrypt and send out the decrypted data all on the fly. So that's what we're doing today in the cloud. And as I said, whether you want to do decryption or not, we actually believe that seeing decrypted data, whether it's in Moloch or Zeek or Suricata or insert any tool you might happen to have, is actually kind of cool. So with that, I think that's all I got. I am glad to answer any questions that you might have.
Two questions. How do you get the symmetric keys?
So, Randy, do you want to provide an answer for that better than me? I apologize. I'm going to call on this person that's smarter about answering how they that because he wrote it.
We actually look inside the memory of the host. It can be a container, it can be Docker, Kubernetes. We'll actually extract and realize where the client hello. I guess I gotta face the speakers. Where the client hello actually starts, and before the server key exchange, we will actually extract the pre-master secret in the master secret. That's for TLS 1.2. For 1.3, it's a little slightly different. But to answer your question, this is on all cloud-based workloads. We will look inside the host or the container itself. It can be, it doesn't actually have to be a VM. It can be a container inside of Kubernetes. A microservice will actually look into the memory extracted.
I should have actually mentioned the one thing that didn't play out of here of my sources. My source is actually a Kubernetes cluster with TLS generation as cron jobs that run every minute. So every minute there's a new cron job that comes up, runs about 300 TLS connections and goes away. So all of that's actually being captured with our agent running as a daemon set on each node.
Neat. And question number 2, can you put the URL back up for the templates?
Yes, sir.
Thank you.
Anybody else?
Thank you all.